Okay, here we go. This question is different from the previous two. It's not going to require us to go as far because these two are about finding the slope. And in order to find the slope, we have to know the derivative. Okay? This question is basically just asking for the derivative. All right? But most, 80% of this problem is the same as what we've been doing. So the limit definition for a derivative is the limit as h approaches 0. You're going to have to know this. This is not going to be given to you. Okay? So that is the formula that we're going to fill pieces in for. The pieces that we need to fill in are this f of x here, which is this. So that is essentially going here. And we need to figure out what is f of x plus h. If f of x is x squared minus 2x, then f of x plus h is 3 times x plus h squared minus 2 times x plus h. Remember that anytime I plug an x plus h into the function, it has to have parentheses around it. Okay? Don't leave the h outside the parentheses. That would be very bad. That would be wrong. So now we know that this is going to go here. And then we're going to simplify this piece. All right, so here we go. So we have the limit. You'll probably want to start all the way on the left side of your page with this. The limit as h approaches 0 of 3 times x plus h squared minus 2, right? Is it minus 2? Minus 2, x plus h, minus, and remember, we're subtracting, so this minus right here is this minus right here. We're subtracting f of x, and f of x has two terms, so we'll want to put both of those terms in parentheses to remind us that we need to take the opposite of each. And here we go. The order of operations, so now we're at this point, we're going to expand this, and then we're going to condense it. So we're going to expand this all the way out, and then we're going to simplify it back all the way down before we get the derivative. The order of operations, I've seen this mistake before. The order of operations says that I have to execute any exponent before I do any multiplication. And so I've seen this mistake multiple times. Don't make this mistake, where people try to distribute the 3 into here before they expand the binomial. Don't make that mistake. Don't be that person. So the limit as h approaches 0, here we go. We've got 3 times, I'm going to expand just this piece, where I have x squared, h squared, and then I multiply these two things and double it. So I have 2xh. I'm going to distribute this negative 2 in here. Oops, sorry. Forgot that parenthesis. I'm distributing the negative 2 into those parentheses, and I'm going to distribute this negative into these parentheses. So we have that statement. Right, take one operation within each one of those pieces. Okay? Then I can distribute the 3. So I have the limit as h approaches 0. Now I'm going to distribute the 3 in. So I have 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x minus h. Now once I've expanded this entire expression, once the numerator, because the denominator's got nothing, it's just got h, right? But once we've expanded the entire numerator, after you've written that statement, check to make sure, I mentioned this yesterday, or in a previous video, check to make sure that every term that doesn't have an h has its opposite in the numerator. Meaning, 3x squared has no h attached to it. Its opposite has to be in the numerator. If it's not, you've made a mistake. You need to go back up and find it. Okay? So 3x squared does have its opposite. It's over here. This has an h, this has an h, this does not, this negative 2x does not. Make sure its opposite is also in the numerator, and it is, because we need those terms to disappear. If those terms don't disappear, we're going to have a problem with canceling this h on the bottom. Okay? So, we have the limit as h approaches 0 of 6xh plus 3h squared minus 2h all over h. We still can't plug 0 in because we'd have this on the bottom, which is the problem here. We need to factor the h away from the numerator, the limit as h approaches 0. Factor the h away from every term up top so that I can cancel it with the one h that's on the bottom. Here. So the limit as h approaches 0 of 6x plus 3h minus 2. And then we can plug in the 0 and get the derivative. A note about terminology and understanding what we're getting when we're done here. Just one more time through. This is the derivative, right? The derivative is the formula that can tell me the slope at any point on the curve, right? This is a curve, this is a parabola. So its change is not constant, but we can find the slope at any point using that formula. That's the derivative. This piece right here is the difference quotient. Okay? That's the difference quotient. It's the simplified form of the difference quotient, but that's what that is. Okay, there's a difference. The difference, when we do the limit, when we evaluate the limit as h approaches 0, and we plug it into the difference quotient, we get the derivative. Okay, that's the terminology. And then with the derivative, if we plugged in something for x, we'd get a slope. This question only asks for the derivative, so we're done. 6x minus 2.